Good morning everyone. Today we have to discuss about factorization. That is prime factorization. What is a prime factorization? When we are doing the product of some numbers, all the product values should be primes. Then we will say that is a prime factorization. For suppose if I take 56, we can write 56 can be written as 7 into 8. 7 into 8. Is it a prime factorization? No, because 7 is not a prime. 7 is a prime, 8 is not a prime. So prime factorization is nothing but when we do the factorization of one number, the product value should be primes. So here 8 is not a prime, 7 is only the prime, because we already know about prime numbers. What are prime numbers? We learned yesterday. 2, 3, 5, 7, 11, 13, 17, 19, 23, 29, 31, 37, 41, 47. Yesterday we discussed about prime numbers. So here these all primes. So in this 7 is there but 8 is not there. 8 is some even number or composite number, so that this is not a prime factorization. How can we change this into the prime factorization? We can write it as 7 into 8 can be written as 2 into 4. Is it a prime factorization? No. 7 is a prime, 2 is a prime, but 4 is not a prime. See, 4 is not there in prime numbers. When the product numbers are primes, then it is called a prime factorization. So it is not a prime factorization. Again you do the product. 7 into 2 into 4 can be written as 2 into 2. Yes, you check once. 7 is a prime, 2 is a prime, 2 is a prime, 2 is a prime. So this is what? This is prime factorization. Prime factorization. That means all numbers should be in the product of primes. All numbers should be in the product of primes. So these all numbers are primes. So these numbers are not primes. 7 2 prime, but 4 is not prime. Here 7 is a prime, 8 is not a prime. So these are not a prime factorization. This is also not a prime factorization, but this is a prime factorization. Why? Because it was a prime factorization. All the numbers in the product should be in primes. So prime factorization nothing but this. Now we will do the exercise problems in first chapter. We have to see exercise 1.1 first question. See the first question. Express each question number 1. Express each number as a product of its prime factors. Each number as a product of its prime factors. First one 140, second one 156, third one 3825, fourth one 5005, fifth one 7429. Okay, so we have to do these numbers, the product of its prime factors. So first I am taking the number 140. So how can we write 140? See, first we have to take 140 like this. So 140 will be cancelled in 2 table. Yes, 2 table, how many times this is? In 14, 7 times, 0 is there, you can down 0. Again 70 will be cancelled, which table? 2 table. Again you have to take the table left hand side. So times, you have to write under the 70, 35. Again, now 35 won't be cancelled in 2 table. No, 35 won't be cancelled in 3 table. 35 will be cancelled in 5 table. Whatever the table will be cancelled in this number, you should be take the table at left hand side. So 35 will be cancelled in 5 table. How many times? 7 times. Okay, see here. Yes, we should be stop. Why we stop here? Because we got the prime number at last. Whenever you got the prime number at last, the product should be over. Okay, now you have to write 140 is equal to, how can you write it? 2 into, again 2 into 5 into last number is 7. So again we have to write as 2 into 2 can be written as 2 square into 5 into 7. If we see the prime, all the product should be in primes. So this is the 2 is a prime, 5 is a prime, 7 is a prime. See the in prime numbers, 2 also there, 5 also there, and 7 also there. So this is what? This is the product of prime factor. This is the product of prime factors. Now see the second question. What is the second question? 156. 156. Again it will be cancelled in 2 table. How many times? In 15. 7 times. 1 is remaining here. Carry 1. This is 16. 8 times. Again 2 table will be cancelled. In 7 how many times? 3 times. So remainder is 1. Should be carry 1 to here. This is 18. 18 how many times? 9 times. In 39, which table will be cancelled in 39? 3 table. You have to take the 3 table. How many times? 30 times. Over. Because why it was over? We got at last that is a prime number. Whenever you get the last number is prime, you should be stopped. Okay, now prime factorization. So 156 can be written as 2 into 2 into 3 into 13. 2 into 2, 2 square into 3 into 13. If you observe the product, 2 is a prime, 3 is a prime, and 13 also prime. This is what? This is the product of prime factors. Now the third question. Third question is, see, there is 3825. So 3825. So it will be cancelled in simply 5 table, because last value is 5 or 0, it will be cancelled in 5 table. So 38 how many times? 7 times. 7 5 is 35. You can carry 332, that is 6 times. So 25 how many times? 5 times. Again 5 table will be cancelled in this. In 7 1 time. In 16 3 times. In 15 3 times. So 133. 133. So is it any table will be cancelled 133?
Huh?
133. So 133 will be cancelled 19 table. How many times it is cancelled in 19 table? See, 70, 7 9s are 63, 7 times. So we got at last 7. This is the prime. So now we can write as 3825 is equal to 5 into 5 into 19 into 7, we can write it as 5 into 5, 5 square into, I am writing in ascending order like this, 7 into 90. This is the product of primes, its primes. Now see the fourth question. So we have to take 5005. 5005, it will be cancelled in 5 table because units place is 5. So in 5 one time 0 0 you can drop, and again in 5 one time. So if you observe this, so in this 2 table won't be cancelled, 3 table won't be cancelled, like this you can continue, and it will be cancelled in 11 table. In 11 table 100 how many times? Up to 99, 9 times. Okay, now remainder is 1 1 1, that carry 1, and this is 11 11 how many times in 11 table? 1 time. Again 91 will be cancelled in see in 13 table. 13 table 91 will be cancelled how many times? 7 times. 7 10s are 70, 7 3s are 21, 70 plus 21 91. So we can stop because last we find a prime number, 7 is a prime. So now we can write the prime factorization of 5005 like 5 into 11 into 13 into 7. Again I am writing in ascending order, 5 into 7 into 11 into 13. This is the prime factorization of 5005. Again to see the prime factorization of fifth one, that is 7429. We should take 7429. If you observe this, it won't be cancelled in 2 table, it won't be cancelled in 3 table, so 4 table, like that up to, it won't be cancelled in up to 17 table. 17 table it will be cancelled. 17 table will be cancelled in 74 how many times? See, 4 times. 4 17s 68. Again the remainder is 6, 62. In 62 70 table will be cancelled 3 times. 3 17s 51. Again the remainder is 11. So we can carry the 11 up to here, 11 9, that means 119. 119 in cancelled in 17 table how many times? 7 times. 7 17s 119. Again 437. So in 437 which table will be cancelled? You can check. See, this is 43. 19 table will be cancelled. See, 19 table will be cancelled in 43 how many times? 2 19s 38. So remainder is 5. Remainder is 5. 57 in 19 table, 57 it will be cancelled 3 times. Okay, right? Now we got prime number at last. 23 is a prime. Stop the factorization. Now 7429 is equal to 17 into 19 into 23. This is the prime factorization, product of its prime factors, because these numbers should be primes. This is the prime factorization of given numbers. Okay.